Autoline After Hours is brought to you by Bridgestone Tires, solutions for your journey.
Hey, Gary.
John, you'd think that after all this time we wouldn't have technical difficulties, but for those who are saying, hey, they're 3 minutes late, indeed, we still have technical difficulties.
That's exactly right. I was running from room to room. I think I got a problem with my laptop or something. You know, everything works fine until you need it to work.
I had to switch out microphones for the first time in like ever. And
that's the way it goes. Hey, we got a pretty interesting show today. We've got Cara Krstolic from Bridgestone, Firestone, talking about race tires. And there she is. She's here with us. And we got Mark Wakefield from AlixPartners as well. And we're going to devote the first half of the show to talking all about racing tires and what Firestone's doing there and Cara's involvement in it. And then we're going to get into some deep industry stuff with Mark later on in the show too. But great to have you both here.
So Cara, you're the chief race tire engineer. Okay. How did you become the chief race tire engineer and what do you do?
Oh, hey, Cara, I think you're muted. There you go.
All right. Is that better?
Yeah, much better. Okay. We can hear you.
That's good. I'm glad. Hard to answer the questions when you can't hear me. It's a quite a long progression story, but I will give you the Cliff's Notes on it. Always interested in science. My mom was a science teacher. Dad was a language teacher. Went into school for engineering. My grandfather worked at NASA, so I thought engineering might be cool. One day I wandered down into a shop where they design and build open wheel tires. So the open wheel cars rather. And so I did that and I thought, wouldn't it be cool if I got a career and I could get paid to work on race cars? So along comes Bridgestone and this opportunity. I find a job in vehicle dynamics. I pester my way into racing. I talked to the manager at the time and I said, hey, you don't have any openings now, but when you do have openings, what is your perfect engineer? He said, nobody's ever actually asked me that question. Let me think about it. He came back and he gave me a few suggestions. I went out and bought textbooks. I learned, I studied. I started engineering street course tires for tracks like Toronto and Detroit and others. And then I moved on to road course and oval tires. And then pretty soon I was managing the engineering side. And then I went to my boss one day and I said, hey, I think we can improve how production is running. I have some ideas. I would love to talk him over with you. And he came back a couple weeks later and he says, why don't you just take the job? So somehow I said all the wrong things and I ended up here. So I love what I'm doing. It's a wonderful job. I've got a great team.
Cara, I love this. I'm a hardcore racing fan myself. And so I'm so jealous of people who were able to get into the racing community. I mean, you wanted it. You just didn't fall into this. You went for it.
No, not at all. Yep, I did. It's all that extra work. I think the volunteering for things that I wasn't comfortable with doing, and I just learned them. So I did.
So what kind of an engineer are you? A chemical engineer or?
A mechanical engineer, a degree in mechanical engineering and a degree in Spanish just to keep me on my toes and keep the Spanish speaking drivers on their toes a little bit too.
Muy bien, señorita.
Yes.
So you are responsible for all of the tires for the IndyCar series. So, it's just you guys. And so tell us about the challenges in terms of developing tires, presumably for different tracks. You were saying earlier that street tires are one thing and ovals are undoubtedly another. And does it change during the season?
Yeah, certainly. So for a typical IndyCar season, we have about 60 different tire specifications. Every tire on the car has a different construction, sometimes even different compounds. So the left front is not the same as the right front. If you think about an oval, like we're here getting ready for the Hy-Vee NTT IndyCar Series oval race at Iowa, the car is always turning left. So what that means is that weight transfers from the inside tire to the outside tire when it turns. You get some pretty aggressive banking and it loads up those outside tires. So the tires need to be more rugged in structure and a more durable compound. So that's on an oval. Street course tires are very different. So you get different types of bumpy surfaces, some smooth surfaces. So you have to be able to engineer a tire that can get traction, lateral force, and braking. If you think about a tire, it's the only part of the car that actually touches the ground. So you have those 4 small contact patches, and that's it, keeping the car from sliding sideways.
Cara, the logistics of this must be mind-boggling. I mean, and IndyCar fields are building, right? You're now hitting 26, 28 cars a race, 4 tires per car, but multiple sets,
Yes.
red and black and green, right? And wet. And how do you keep track of all this, especially if you have specific tires for specific sides of the car?
Well, certainly. We have a great logistics partner out of Indianapolis, Performance Tire Service Company. They do an amazing job helping us with logistics at track. But if you think about a typical race like last weekend, you talked about rain tires, you talked about the green sidewall alternate tires, and we'll talk about those in a minute, hopefully. And then our primary tires, that's 12 different sets of different specifications there. So we have to track all those tires, make sure all of them are mounted correctly, they have the correct inflation pressures. When we come to the racetrack, we're monitoring all of that while we're at the track. So getting feedback from the drivers, making sure the teams have the right pressure, the cambers look good, making sure that they're getting the best out of their tires.
Okay, if Mark has a car and John has a car and I have a car and you have a car, do we all get the same package of tires at the beginning of a weekend?
Yeah, if you're a rookie, if this is your first year doing a broadcast, you would get an extra set of tires. So rookies get an extra set because they need a little extra time to be able to learn. So other than that, everybody gets the same primary, alternate, and rain tires.
And so let's talk about the different compounds that are used at the race. You talked about the primary tire, which are the blacks, right? And I guess the alternates, as they refer to them, used to be red, but now they're green. Is that right? Go into that.
Yeah, so on road course, they're reds, and on street courses, they're green. So a primary tire is a nice, durable tire. So you're going to get the same performance on the first lap, and you're going to get similar performance on the last lap. You're not going to have a lot of what we call drop-off. Drop-off makes racing interesting because it can put people on different race strategies. So our alternate tire has a softer compound with more grip. So that higher grip is going to make faster lap times initially, but because it's a soft compound, the compound will start to go off or degrade over time, which makes the last lap slower. So ideally you have a nice consistent primary and then an alternate that's quicker, but then drops off. So there's some transition point to when you really want to be on the primaries instead of the alternates. And the teams can choose. They have to run one of each during the race. And depending on how they run those, that might help their strategy or it could end up hurting their strategy. So it gives a lot into the hands of the drivers. So drivers that can really take care of a very soft tire can get it to last a little bit longer.
So Bridgestone has a goal, like many corporations do, to go carbon neutral by 2050. And it also has a goal to use recycled materials in its tires entirely by 2050. So this year at the Indianapolis 500, Firestone did something different in terms of formulating its tires. Talk to us about that.
Sure. So as you mentioned, Bridgestone is very invested in sustainability and has some pretty ambitious goals. And as a race tire design engineer by trade, having understanding we need to put sustainable materials in our tires can be a challenge because you don't want to sacrifice performance. You want to have the very best performance you can have because the drivers depend on that durability and reliability of our tires. So we were looking for ways to be able to incorporate sustainability, and we'll talk about the green tires in a little bit, but for the Indianapolis 500, there is no, we use green rubber, Wiley rubber in the sidewalls, but there's no natural rubber in most tread compounds of racing tires. We have synthetic rubber. So we worked with some of our partners at a few different organizations, including Shell, to see if we could work with them to develop a sustainable monomer. So if you think about a tire, it's really sticky and it sticks to the racetrack because of its tread compound. That tread compound is made grippy because of the polymers that were in there. And a polymer, if you think about it like a very long paperclip chain of monomers, those paper clips are the monomers. So we use things like butadiene as a monomer, and we were able to work with Shell to get post-consumer recycled plastics as the source for the monomer, as opposed to fossil fuels. So we're getting those pesky Walmart bags, Target bags, Hy-Vee bags that we can't recycle. Shell is able to take them and turn those into the butadiene, and that in turn goes into our polymers.
Cara, I always believe that, racing improves the breed, and it's a great test bed for ultimately production technology, mass production technology. Is that happening at all with your race tires? I mean, is production technology going to racing or vice versa?
Yeah, certainly. We've been challenged, and it's been very impressive over the last few years that we're starting to do things in racing that actually make their way into the passenger car world. So if you think about our cars, you and I are not going to go 240 miles per hour down the interstate. I highly recommend not doing that, but our Indy cars are. So there's not a lot that transfers as far as tire performance wise from an Indy car to a passenger car. However, there's a lot of technology that go into tire development that can transfer. And one of the premier ways to do that is through things like sustainability. So we're using this ISCC certified monomer, sustainable monomer, in our race tires. And we're also looking at doing some demos of some passenger tires. So this is something that you will see in your Bridgestone and Firestone tires in the near future. And some of the other things that we've been doing, we talked a little bit, alluded to the green tires a little bit. That green Waiuli rubber, we're debuting in IndyCar. There's a great picture on the screen right now of the IndyCar Waiuli rubber sidewalls, those green sidewalls. So that Waiuli rubber is a replacement for the Havea rubber that goes into the tires normally, and we are working on scaling that up, so we'll see it in passenger cars in the future. So we hope to be full scale by 2030, and we'll be able to start putting that into passenger tires soon thereafter. So why Waiuli is important? It's a desert shrub that is native to the Southwest United States. It is a low water use plant. So instead of getting Havea from Southeast Asia, we're actually getting Waiuli from the United States. And it is a really hardy crop. It can grow in areas that are drought ridden, uses about 50% of the water that something like cotton or alfalfa would run, and it runs in pretty hot climates too. So it's a great crop for some marginalized areas, and it's neat to be able to see that used in our IndyCar tires.
So what is the other? Haeva is the other.
Havea. So if you've ever Googled where does rubber come from, rubber comes in a lot of different sources. Our main source of rubber is the Havea tree. Havea brasiliensis is the name of the tree, and it has a beautiful wood, but it also has in order to get the rubber off, you cut it in a long spiral, and the rubber basically weeps out of the tree. It's a interesting process. That rubber is then smoked, and then it's shipped to the United States. But there's a lot of carbon impact in getting the material from there to the U.S. as well. So the trees are really single sourced. When we talk about most of our natural rubber supply in the U.S., it's coming from these trees. If there were to be a blight or a drought or something that would affect these trees, we would be in a really difficult situation in how to get things like latex that's used across the surgical industry, tires, and a lot of other places too.
Yeah, it's what, from Indonesia, Malaysia, Indonesia? And hasn't there been problems with the trees in the last few years?
Yeah, certainly. There can be things like bugs or specific pests or insects that might attack that tree. We've seen funguses and other things like that. So trying to make sure we protect that natural rubber supply is also very important.
So you mentioned how you can test these materials in racing and learn things fast, I'm pretty sure. But part of your title, says manufacturing in it too. Yes. So I got to believe you're learning manufacturing processes using these materials.
Yeah, certainly. So I get the great pleasure of leading both the engineering and production teams, the manufacturing teams. So we're working to utilize these different materials and understand how they're used and how they're processed. And sometimes we get something that is chemically equivalent, and sometimes we have to incorporate a material that's just a little bit different. So looking through those, how to make everything very consistent, making sure you have the same performance out of the tires, regardless of the source of the material. That's one of the things that we pride ourselves in, and being able to be consistent, because that's what the race car drivers need, is that consistency.
Mm-hmm.
So Mark, I got to ask you, hearing what Kara's saying about the development going from one side, from racing to production, when you're talking to OEs around the world, are you finding that companies typically do that, if that are in racing for total vehicles, or is there a disconnect?
The development teams, you mean?
Yes.
Yeah, there's a pretty big disconnect. They'd love to see technologies come in, but the scale, the durability, right now the challenge in tires, around noise, EV torque, and what it does to tires, and these sorts of things are a little different than racing. But racing does improve the breed, so you do see the engineers that come from the racing programs, and they've always just got a spark to them. It's a fantastic thing to see.
It's interesting, and Cara, I don't know, maybe you can correct me if you know this better than I do, but American companies tend to run their racing budgets out of their marketing departments. European and Japanese companies run it out of their R&D budgets. And so it's a very different approach. Marketing budgets go up and down. R&D budgets tend to be much more steady. And I think there's a difference in that regard as well.
I think it depends on the company. We race to learn, and we race to understand and make our pasture tires, or even for original equipment manufacturers to make their vehicles better. But at the end of the day, you think of what Harvey Firestone said back in the day: win on Sunday, sell on Monday. So there is a very, very strong pool for marketing to make sure we are able to present our brand in a very favorable manner, and to be able to sell tires at the end of the day. Because yes, we're there to learn and to make sure it goes over to pasture tires, but there has to be a business case to it as well.
So, Cara, I've got another question for you, which relates to Formula One, but I think it ties back into the work that you do. As you know, Formula One, there's so much of a challenge of lighting up the tires, getting them to the right temperature. And if you nail it, wow, you've got a great race car in your hand. And if you can't, or if it works for part of the time of the race, and then it's all screwed up. IndyCar doesn't seem to have that problem. Is it because of the way that you've constructed the tires? Is it because in Formula One, everybody's building their own chassis? They're all different. In IndyCar, they're all the same. I mean, what's the difference there?
So different companies use different polymer makeups, different constructions, and that is part of the trade-off of a racing tire, is how quickly it comes up to temperature, and then how long it can stay at that peak operating temperature. So that's something that our compounders, our chemists, and our engineers put a lot of effort into, is ensuring that we have the correct polymers in there, in the correct makeup, and then the structure can best utilize those tread compounds in order to keep that peak grip up. So a little bit of a long-winded answer there, but I think it's really important that you design the tire around all of the vehicles. Even when we test an IndyCar, we have a Honda and we have a Chevy. We make sure we test with both manufacturers to level the playing field as well as best as we can.
Mm-hmm.
So if you look at a passenger car tire, the treads all seem to be different. I mean, they're just endless tread patterns. And yet when you look at race tires, they're very little in the way of tread patterns. Does it not matter?
So when you are running in dry conditions, and keep in mind with an Indy car, it takes longer to put fuel in the car than it does to change all four tires. When you're racing in dry conditions, you want to have as much of that tire in contact with the road surface. We talked about those 4 little contact patches are all that keeps the car connected to the ground. You want to have 100% of that contact patch in contact if you can. And if you have grooves, that takes away area from that contact patch. So if we can eliminate the grooves in the race tire, we're going to get more traction. Now, let's let water enter the picture. It starts to rain and you've got water on the surface. You do not want to have a slick tire on a wet track, because the water has nowhere to go. Water, in fact, is a great lubricant for rubber. So you put it in between the rubber and the ground, the car is going to slide. So once you go to rain conditions, you need a pretty standard rain tire construction with a rain tire tread pattern in order to get that water away so that tire can touch the ground.
Cara,
and does that pattern change over time? I mean, do you come up with different patterns and, run simulations and make a determination, this will be better than the one we used last week?
No, we typically will have the same rain pattern for several years, unless there's a reason that we need to change it. We typically don't change the pattern itself. We might change the compound, but we wouldn't change the pattern very often.
There's so much talk of using artificial intelligence today in all aspects of society, but the auto industry getting into it too. How about you guys? Are you using AI in any of your development?
So I think the closest we come, we do some neural network modeling when it comes to our tread compounds. So we have a number of ingredients that go in, and we have some results that come out. So using something like a neural network model can help predict what our performance of the tread compounds are going to be, and it also can help suggest some potential recipes.
So go ahead, Gary.
Well, I was going to say, one of the issues that seems to be vexing in races after there are accidents, despite the cleanups, that there is often some carbon fiber bits that end up giving tires flats. I mean, is that an issue that you guys are trying to figure out, how to keep tires from getting flats during a race?
Well, it would be very difficult to completely keep any flats during a race, because those carbon fiber bits are very, very sharp. You have things like a car driving into another exposed wing, and even at Detroit, we had a lot of interference with some of the bolts that were sticking out of the walls that they had put up, the temporary walls. So you need to make sure you design a tire as lightweight as possible, because again, these tires at Indianapolis are going 240 miles per hour and then turning into turn one. So it's anytime you have too much gauge or too much material, you're going to generate heat, and heat is the enemy of a race tire. So we want to make them strong, and we have some very interesting alternative materials in there that make them strong and lightweight. But you don't want to over design it to the point where you're not going to get any flats and then cause issues with heat and durability.
Cara, I'm curious about your work life. I mean, I'm sure you go to every race, right?
Most of the races, I try to miss about 2 or 3 races per year, so I can give some of my younger engineers a chance to be a leader at the racetrack.
Okay, but you're working every weekend, and,
Yes.
and you're traveling all over the country, and you were just in Canada. There's talk of maybe IndyCar going overseas. Argentina, for example, has been mentioned. How do you do with it? I mean, after a race, do you get Monday and Tuesday off, or do you work 7 days a week?
Well, I try to make sure my team has days off. They can take days off in the week when they work the weekend. I don't necessarily give myself that opportunity. I should. I have a very patient husband, and that helps tremendously. And then I have outlets when I'm on the road. Like right after we're done with this, I'll probably go out and take a jog around Des Moines area. And it's important to have outlets. And then for me, like music. So when I go to Indianapolis for the month, I'll actually take my flute with me, and I'll practice while I'm there, because it's a really, really good outlet, is to be able to have the physical outlet and then also music.
So you're still excited about it, right? I mean, you're not thinking, oh my gosh, what am I doing here?
There are certainly days that give me more gray hair than other days, but I love racing. I'm passionate about what we do. I'm so passionate about the company and these drivers that work with us. They're more like family than customers. The IndyCar paddock is so close that if something happens to one of the drivers or one of the team members, everybody's there. So it's, I kind of call it a little bit of a traveling circus.
I knew you would be interesting to talk to, but a flute player, I never would have taken you for that.
Yeah, everybody has their unique abilities, and I think it's just important to keep yourself challenged, and that's a good way to keep myself challenged.
Real good. Hey, I think this is a good point to wrap up this segment. And Cara, I want to thank you so much for having come on the show. Very, very interesting. Like I said, as a hardcore racing fan, I am so jealous. I wish I was smart as you, to be able to have broken into that field, but it never happened.
And persistent. I think you've got the persistence, though.
Right. Real good. Well, thanks so much for coming on. And in fact, before you go, I got to tell you, we're about to take a break right now. And it happens to be Bridgestone. That's the sponsor.
Excellent.
Yeah.
Okay. Thanks,
So
Cara.
have a great time in Iowa there.
All right. Thank you all. Have a great
Bye-bye.
day.
How do Bridgestone tires stop shorter on wet roads? It's their HydroTrack technology. But you don't have to know how the science works, just where the brake is. What really matters is their Bridgestone.
All right, we're back. And we're going to change topics here. But Mark, you're a bit of an enthusiast too. What did you think of all that stuff? Talking about all the tires there.
Oh, it's pretty neat stuff. Yeah, and I'm with you. I think from a passion perspective, being smart enough to figure out and then persistent enough to get into that would have been pretty cool.
I love it. I like people. I so admire them that, just didn't fall into a career. It just didn't happen. They went for it. And I mean, that's how I got into it. I wanted to get into what I'm doing here.
Yeah.
So Mark, AlixPartners did their annual Global Automotive Outlook, and there was one top line that came out of this that I want you to talk about because I think it's fairly compelling. Chinese automobile companies are poised to become the shaping force in the global automotive industry in the coming years. Unpack that for us.
Sure. There's a lot to unpack in that, but I'll try to be quick. We've seen a lot of dismissal of Tesla over the last 10 years. And then in the last few years, a lot of focus on Tesla from traditional automakers and from Western automakers and Japanese and Korean automakers. And now, taking the lessons learned and trying to apply those. But while that's been going on, the Chinese for the first quarter, actually the Chinese brands outsold foreign brands for the first time in decades in China. And they did it also by competing in the NEV segment, so plug-in hybrids and battery electrics. And they're doing it with different operating model and different ways of approaching the business that are meaningfully different than the traditional business and the traditional ways of working. And it's not just one element. It's not just things like you've heard of sort of software-defined vehicle or gigacasting pieces that Tesla's doing and some other pieces. There's really a holistic nature to it. And while the export market isn't critical for China or Chinese brands yet at the moment, in our work helping automakers, both domestic Chinese as well as foreign automakers in China, we sat back this year and said, there's a lot of these elements that they may not be critical now in Europe and in the United States, but they will be quite soon. And the export market isn't critical to China now, but it might be in 3 to 5 years' time, about the amount of time it takes to make some of these changes. And it's pretty clear there is a winning elements of an operating model that are very tough to change, but are very critical to change. And the first people that make those changes successfully are going to be set up well for the future.
Well, Mark, let's go into some of those. I mean, if you do a lot of restructuring of companies and everything like that, and advice to automakers and suppliers, what's the advice? What are you telling them? Hey guys, you better be doing these things or you're going to get your clock cleaned. What are the specifics of what you're telling them?
Yeah, there's a lot of work on helping companies pivot to a new model and helping them pivot to electrification. We coined the term CASE in 2014, connected, autonomous, shared mobility, electrified. And across all of those are big changes to how vehicles are developed, how vehicles are manufactured and sold, and how they're experienced by consumers. And so for example, in China, you see a BEV first focus. You see it unencumbered by the same type of cost and capital focus. You see a focus in the engineering teams on different things. So styling, interior, exterior styling, new tech, and really pushing the envelope. And not just like porting your iPhone screen or Android screen on your phone, but actually things like ADAS and other very intense technology. The take rates on Chinese branded across the price spectrum. Chinese branded companies, the take rate on ADAS is higher than on foreign companies in China. The speed, the average age of an NEV is from the NEV new startups is about 1.3 years. It's about 2.5 years for the traditional Chinese domestics in EVs, and it's 4 years, over 4 years for the foreign automakers. So speed to market is incredibly important. And you say, okay, those things sound great, but what's the trade-off? The trade-off is things like putting the pencils down on NVH, on power, on comfort, on some things like that, where in foreign automakers, there's sort of a continuation and a continuous improvement, really coming from the beginnings of Toyota Production System and all that, of let's change things just a bit, let's freeze a design 6 months, the first 6 months of production. Let's architect things up front, but then not make changes in the first, the 6 months before a launch. And these sorts of things that when your back's against the wall and you're fighting in the kind of competitive market that the Chinese NEV market is, you don't have the luxury of doing that. You have to have consumer technology, consumer engagement, and you have to have fresh styling, things that will appeal and compete in what is the world's largest market, and it's the largest growth segment of the market. So there's a lot to be learned from that on the trade-offs, on the what to throw away and what to protect from the lessons learned of the past, and how to not end up bringing a knife to a gunfight.
So let me ask you about two things that you said in that. One, you said that the Chinese are taking an NEV first approach. And if we look at, say, in Detroit, they're seemingly balancing the two things, because at this point they're making all of their money off of ICE pickup trucks and large SUVs, and that's funding their work. So they can't necessarily have that approach. And the other thing I think is interesting is the whole discussion of NVH, ride and handling, things that are historically important to vehicle development in the United States, because if a car is noisy or a car doesn't handle well, the OEM will be eviscerated for doing that. So yeah. How does an executive or a manager at a Western car company suddenly say, hey, we've got to start thinking differently, we've got to perhaps think NEV first and really put the others on the back burner? And then in terms of the engineering attributes, BMW didn't become the ultimate driving machine by not paying attention to ride handling and performance.
Yeah, but people aren't buying the ultimate driving machine. They're buying style, and they're buying technology, and they're buying one-to-one customer interaction. And so being new tech driven, and it's not enough to just have a safe area for risk. It has to be a mandate to take risk, and to take it smartly and to take it fast, to balance those risks holistically, and to come in on time and on budget versus slaving away to get the perfect vehicle and hit your marks on your NVH requirements and your other requirements, kind of regardless of cost and time. Almost, you don't have that appetite in the winning Chinese NEV companies, and they don't have the luxury of doing that either to be successful. The other big piece is scale. I mean, you see Tesla and BYD with massive scale and making money off of it, but not having made money before they get to scale. And so there is in the Chinese market, a lot of aggressive pushing of volume by cost and by technology, by styling, by any means necessary. You see customer engagement and direct-to-consumer sales approaches, lots of things that are eviscerating a lot of money, but are trying to chase scale to become profitable through that. Because being right and small isn't going to be a winning, surviving type of strategy.
So, Mark, let's go back to what you were talking about of Western automakers freezing specs. I mean, everybody learned from the Toyota production development process. Freeze everything a year before job one, and then concentrate on making sure that you can productionize everything there. Because as you know, as you introduce design changes, that introduces variability. Variability inevitably leads to quality problems. So are the Chinese just living with quality problems, or have they figured out a different way of getting around that?
So there certainly are quality challenges with having such an agile approach to vehicles. But it also forces you to architect things up front in a different way that allows you the flexibility to change things quicker as it goes. Things like your instead of zonal, having central electronics architecture and being able to core hop your app. So having a function move from one ECU to another fairly seamlessly, you have to architect that well up front. But that then allows you to go, oh my gosh, I need my brake controller to do this, 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 this. Put more code into that. If it absorbs the full of that ECU, you port something off of that. And if you've architected the system up front to be able to do that, you've got some basic cyber connections and protections to do that as well. You've allowed yourself the ability to make a change safer and faster versus big tear-ups like a new MCU, for example.
One of your findings was that in the middle of the mid-segment market in China, that the average age of cars is 1.3 years, and the non-Chinese companies in market 4.2 years. How are they achieving that speed?
Well, the 1.3 is the NEV dedicated brand. So many of them are startups with a newer vehicle, with not a traditional one. But even if you look at the Chinese legacy brands, it's 2.8. And so they're achieving that speed by putting vehicles out there and refreshing them faster and not letting them linger. So there is a freshness to this market that works. And the Chinese are seeing that and seeing the importance of freshness on exterior style and even interior style and tech features being important.
So I've got to ask, are the vehicles that are being manufactured in China as robust as vehicles that are built by Western companies, or are these vehicles being built in China with the notion of there'll be a quicker changeover that people will swap out of their cars in a very short period of time, so we don't need to worry about 10, 12-year durability sort of thing?
I'd say it's a combination, depending on some of the startups are clearly cutting corners that are visible on the vehicles, but there's a lot of fantastic vehicles. You look at some of, I won't name the names, love all my clients, but some of them are fantastic designs, and they drive well or well enough, and they have features that may not work all the time, but Chinese consumers are accepting that to get more features in. And it's not just, again, the infotainment, things like lane changing and crash avoidance by lane changing. And there's an acceptance of it not working perfectly as long as it's in there versus not having that feature at all. So there's a willingness there's enough positives and surprise and delight that allows some of the things that are slavishly looked at in traditional automakers to be forgiven as long as they're addressed well. Like, it matters quite a bit how well it's addressed, not just did the incident happen or did the problem happen.
Mark, I'd love to get your take on the approach that legacy automakers, especially Western, including the Japanese and Koreans, excuse me, ought to be considering. Three major automakers have carved out essentially startup units within their own businesses that are total standalone EV focused, like you're talking about. Yeah. Others say, no, we can handle it the way that we've always done it. Where do you think the winners are going to come out of? The ones who have got tried and true and proven processes, or the ones who are gambling and going the startup route within the company?
I think the startup route has to go even further. I think there's a third category of going even further and having the ability, having the the freedom to actually challenge on first principles engineering, to challenge on re-architecting how you put a vehicle together. Because even some of these carve-ups are still leveraging an awful lot of the existing traditional automakers' design and development process. So things like, you know, how a vehicle gets architected, thinking about thermal and electrical first, rather than the body and size and you know, powertrain of the vehicle. You know, you have to architect and rethink the way you're coming about the vehicle, its manufacturing, and how the consumer is going to interface with it. And if I personally don't even see the really any of the traditional automakers yet fully embracing how much change they really have to do. So I would even put a third category of the winning category being further out than those two.
So Mark, is this more of a consumer electronics company mindset that's required for the automakers, meaning that there's a constant churn, a constant change, a constant development and redevelopment of product?
To a degree. I mean, you have, of course, the issue that if your phone doesn't work, nobody dies. If your car doesn't work, it could, right? So it's a different animal. But on the spectrum, it's also not a nuclear facility that, you know, 1 million people die. So you've got a spectrum of risk that you need to take into account. So it's not just, there really isn't a copy paste. The closest copy paste is these new NEV companies in China, and how they're operating is the closest copy paste. And getting attention to the lessons learned from those, not just the current focus of what's Tesla doing, I think is a bit of a pivot that I'm talking about, and having the courage to do it holistically rather than in piecemeal by a piece of design or a piece of manufacturing or a piece of sales.
Mm-hmm. Do you think it would be conceivable that a company that has traditionally done things the way they've done them for many years, then, as you say, Tesla comes up, at first everybody's like, that's nothing, forget about it. Now everybody's like, holy moly, we've got to start using some of the processes and practices that they do. And then you're suggesting that some of these startup NEV companies in China are even beyond that. And I wonder whether the traditional OEM doesn't need to graduate to the Tesla before it can go to the next level? Or do you think that they just need to somehow leap to the next level?
I think that they're better than Tesla in many areas, and they need to leverage those. But it's about being smart about how you leverage it in a whole system, and being aware of what's beyond that what needs to get looked at. Because this isn't the first time this has happened. If you look at the US, you see the Japanese in the 70s, and then the Koreans, and then Tesla. And so let's get ahead of the next wave coming.
Where do you think some of the Chinese automakers are ahead of Tesla, and what should Tesla learn from them?
Well, being new tech driven and really driving freshness in, when you've got 60-some% of the U.S. market of EVs, the freshness doesn't quite matter as much. I think it will matter for Tesla in the freshness of vehicle design. I think the usurper mindset versus defender mindset is something that creeps in when you are the benchmark people look at in a market, and I think you can see some of that with how well companies like BYD, NIO, and others have created brand impressions in China. And then as you get large, stop protecting against a siloed engineering-driven approach to optimizing what you need for a vehicle, and instead keeping and maintaining a laser-focused customer approach to what will attract customers.
Yeah, it's interesting you say that, and you mentioned BYD and NIO. I'm not sold on NIO yet, only because they seem to have some real financial problems, and that maybe that goes back to your early comment, which I think was so spot on, of it's a race to scale. But BYD, oh my gosh, this company, I've had a couple of very senior level Detroit-based auto executives tell me they think that BYD is out Tesla-ing Tesla.
Yeah. It's impressive what they're doing on their electrical architectures, on the cost that they're able to hit for what they're able to deliver. If you walk through the Shanghai show, it was a ghost town around the foreign brands, and people were quite interested in the Chinese brands, and shows you what they're doing right. And I'd say in the NIO one, if you look at the customer engagement they have and the way they engage one-to-one on customers and make a community is really impressive. But as you said, losing a lot of money, like Xpeng and a few others. So a bit of a race to scale and a bit of just like Tesla had, a supportive investment community behind them that's required. If people lose confidence, then you don't get the capital to make it to that point.
Mark, one of the things that you guys identified in this study was what I would describe as structural issues that the traditional OEMs, and let's just bring it to the United States in this regard, because I'm not exactly sure of the way it happens in Europe, that the Chinese companies have direct to consumer. They're not needing a dealership network in there, and the domestics here all work through a dealer structure. And the other thing was that these new companies, because they're new companies, they don't have legacy plant and equipment predicated on building ICE vehicles in a way that they've pretty much always built ICE vehicles. And, so that's a big hurdle to deal with. So how does this get sorted out?
Well, it's difficult. There's a few different approaches, but if you try to transition your entire plants and workforce from a ICE world into an EV world, unless you grow market share significantly, you're going to be doing things inefficiently and artificially, and that's going to cost money. So when we've looked at it, it takes about 40% less labor hours in the powertrain organizations, in powertrain manufacturing, to put together an EV powertrain than it does an EV. Than an ICE vehicle. So again, not the whole vehicle, just the powertrain. And if you then said, okay, I'm going to take the engine out of that, you would, an engine is about half. So you get the ability to put people to work on the things that make the most sense, rather than sort of force fitting them into a vertical integration approach and trying to, make chemists out of mechanical engineers or other things like that are a little more difficult. And so again, it's sort of the courage of conviction and the use of these fantastic balance sheets that have been created over the last couple of years to go after the type of change that allows you to compete heads up. I've used this thought exercise with an automaker before. Okay, if we're going to transition this engine plant, instead of building transitioning just the transmission plant into an e-motor and battery assembly piece. If that's the right thing to do, we should be able to sell an engine plant to a startup or to an EV company. And then, would we ever do that? Well, no, we couldn't do that. They wouldn't buy it. So if another company wouldn't buy it, it's not an asset to be leveraged. It's something to be dealt with, and it doesn't mean deal with all of them now. Obviously, ICE will be around for quite some time, but find the right way to manage it for cash flows and in competitive nature, and not be in a melting ice environment, which boiling frog you could say, but ice melting works with the internal combustion engine.
Well, Mark, let's continue, because that's fascinating. As you know, ICE sales have peaked globally, probably. Well, not probably. Globally, they've definitely peaked. But as you know, if you're making ICE powertrains, you don't have to wait until it all disappears. If you lose 10% of your scale, you're in trouble. If you lose 20%, it's no longer profitable. I mean, how do you think that's going to play out? Because, when I ask automakers, how are you going to deal with it? They don't want to talk about it. They know it's coming. But I mean, I think they also don't want to scare the people who work in the plants and their families and communities and all of that.
Yeah, I think there's ways to do it, to be competing in that market, but to be able to take capacity out, to take options out, to take things down. So you're managing capacity in chunks, and you're managing utilization at a plant on a shift level in quantum chunks, rather than letting that sort of drip from 80 to 70 to 60% utilization, which murders the profitability, cash flow, bonus checks of employees, jobs of employees, and all that stuff. So it does take forethought to be able to plan that properly, and a different way of thinking about what's really needed in consumer choice.
Shifting a little bit, another one of your findings was that the top 300 global suppliers had $30 billion of debt added to their books. And it seems to me that many OEMs are relying on suppliers for new technology. How do these suppliers, A, exist, and B, find themselves capable of, funding the R&D that's necessary to come up with the new batteries and motors and whatnot?
Yeah, automakers have taken the benefit of being able to change price by taking incentives back, mix, trim, all these things. But a luxury car isn't necessarily that much more profitable as a bumper than a volume car for a supplier. And so suppliers, because also having fixed costs that you've got to go back and claw your way through as a negotiation to get an increased price if volumes drop or if inflation goes up, have meant that they've used their cash balances to fund the business and to fund that through, while the automakers have used cash to buy back debt and pay down debt and be in a better position. And so you're right, it is a much rougher starting position of suppliers right now than automakers. And it was flipped. The automakers were the ones that had rising debt loads going into COVID, as sales had been sort of flatlining since 2017 a bit. And now they're the ones with strong balance sheets, and suppliers having a tougher spot.
Mark, as automakers, especially with their electric vehicles, move to software-defined vehicles, they want to bring all that coding in-house. You've got major suppliers who have accumulated a lot of software capabilities over the last decade. Where is that going to lead them? And especially a secondary part of that, as automakers want to insource more, not just the software, but they want to insource more. And of course, with the Detroit 3, they've got, job commitments to the union and whatnot that play a role in that. How do you think suppliers can manage this?
They certainly have to recognize that there's an elephant in the bed and they're the mouse. So, watch where the elephant is rolling. It takes 5 automakers to make up 50% of the value add of automakers globally. It takes 50 suppliers to make 50% of the supplier value add. So the buyer-supplier power is clearly in the favor of an automaker, and that means you can't really move too much. Obviously, you've got a number of suppliers that have great technology that's protected and they're needed, but the vast majority of suppliers are in more, the OEMs use the word commoditized, but more standard cost-plus kind of environments, and where you're competing on execution rather than necessarily software engineering and software. So finding ways to dovetail. So if you've got an OEM that's focused on allowing edge computing in your lights or in your brake controllers or in your other components, great. You have a part to play in that, and your software shouldn't be based on trying to be the central body controller. It should be on how do you participate with that by edge computing. And it depends quite a bit by one OEM to another. So some automakers are trying to grow that capability internally, and others are trying to set certain standards and certain interoperabilities but allowing suppliers to spend the money on some of the ADAS elements, infotainment elements, some component control.
Mark, as you well know, the UAW negotiations are underway. And one of the findings that you guys had that surprises me is that U.S. automakers now need 25% more employees per 1,000 vehicles produced than they did before the COVID pandemic.
Yeah.
How did that happen?
It's similar to the pricing piece, right? When you have the ability to change price, you want to get every last vehicle out, and so you're willing to run very uneconomic shift patterns and schedule patterns to make that happen, and have people around because you want those vehicles out the door. When you're a supplier that doesn't have the pricing lever, and you want to run efficiently and effectively, you want to push back on the requirements of automakers to staff up to prior volume levels, and you have to watch the labor cost. Labor cost isn't the biggest cost item, but you have to watch that labor cost item. So it's a bit of the nature of the economic incentives of an automaker versus a supplier that's led to that.
Mark, we started out this conversation, talk a lot about the Chinese. I'm bringing you full circle back on this one. When do you think they'll make a serious run at the American market? I mean, the Chinese market is the biggest market in the world, but I believe the American market is still the most profitable one. They're going to want to come here. And when do you think that might happen?
Well, right now it's very protectionist, so it'd be very difficult. With the 25% tariffs, with other pieces, it's not so easy unless you build a plant here. And even if you did build a plant here, not so easy, as we saw from the recent plant discussions on Michigan versus other states. So it doesn't seem terribly imminent in NEV companies coming. The world can change in 3 to 5 years quite a bit politically, and the environment for that. As well, you have you already have the Buick Envision, you've got a Honda, you've got a bunch of vehicles that are made in China and brought here under the brands, under Western or Japanese brands, under traditional brands. And that's going to just continue, particularly in more of the premium markets where it doesn't make sense to tool up multiple plants for a vehicle. But my points about the operating model of the future is not so much about if these Chinese brand companies come over to the US. It's that even if they don't, if another company is able to fully embrace this, it looks like a winning strategy.
Well, good. Look, we're just about at the top of the hour here. That's probably a good note to wrap this up on. But Mark Wakefield, thanks for coming on again. I love having you on this show. I always learn so much from you. So it's always a treat.
Well, thanks very much, John. Thanks, Gary.
Thanks, Mark.
Well, good. See you next week, Gary.
Indeed, will do.
Okay. Want to thank everybody for having tuned in.
Thank you.
Autoline After Hours is brought to you by Bridgestone Tires, solutions for your journey.
If you like this program and would like to learn more about the automotive industry, check out our website at autoline.tv or look for us on YouTube on the Autoline channel.